Hello everyone, welcome back to the next lecture on costing in metal additive manufacturing. This is the part 3 of the costing lecture series. I would just like to recall the cost model in different perspectives that we looked from the finance viewpoint, from the management viewpoint and from the manufacturing viewpoint. Now in this lecture, I would like to introduce or discuss a model that is more focused on the manufacturing viewpoint of the costing, in which pre-processing, processing and post-processing costs are calculated, in which further we have direct and indirect, fixed and variable. In the terms of fixed and variable, we will have the materials, labor, energy. So how does this cost model is built upon? So it says all additive manufacturing processes, activities and their constituent parts are taken into account when developing a cost model. The total cost per part is calculated using the given calculation here. Given that some additive manufacturing systems can create n parts during a single build, the total cost per part is expressed as this. So total cost is equal to 1 by n, where n is the total number of pieces that could be produced during a single build, and C prep is the cost of preparation, C processing is the cost of processing and C post is the cost of the post processing. So it is preparation means pre-processing, processing and post processing, 3 parts of the cost are divided into it. So if I try to just plot the total cost as a model, total cost model has 3 major components, or I would call it 3 activities, that is pre-processing, then processing and post-processing. Pre-processing generally includes, because no material is much involved in it, so it only has the labor and overhead. And the processing involves material, energy, right? Then we have machine, labor, process control cost, then we have overheads. So these factors would come in the processing cost. In the post processing, again we will have material, machine, energy would be instituted here as well, and labor would also be there. In this case, post processing, we need to have some testing costs associated and overheads are always there. So these different costs, let us try to see various models. So these are the activities majorly, pre-processing, processing, and these are the elements of the activities. So the sum of the cost of the 3 categories or activities make up the overall bill cost. However, specific components should be looked at in order to estimate the cost of each of these activities. The associated cost components have also been shown for each activity in the previous illustration which is there. Now the pre-processing activities can be categorized as labor and overhead cost. The processing activities are divided into elements of material, machine, labor, energy, processing, control, costs during printing of the part and overhead costs. The third activities cost components are material, equipment, labor, energy, testing and overhead expenses. Now, there are certain calculations for the pre-processing cost, for the processing and the post-processing cost. Let us first see the first calculation that is given here. The pre-processing is the initial additive manufacturing activity. This activity includes all of the preliminary work required before construction. In this activity, labor and overhead costs are involved. Cost of pre-processing is obviously cost for the labor and cost for the overhead. So, this is labor, this is overhead. Here 1 indicates pre-processing, right. So, these all costs are in rupees. An operator is required to carry out several tasks during pre-processing. The operator needs to have a CAD file to begin the pre-processing activity. This file must be converted into an STL file. The build orientation must be changed or be put into the right form, into the right place, so that we get the optimal or the minimum time and the minimum investment. So, support structures are to be designed, the build must be sliced and layer thickness must be chosen. So, all these becomes the part of the labor itself. So, the pre-processing activities are categorized here as labor and overhead majorly. The processing activities again include all those what we have mentioned before. Next is, what is the cost of the labor? It is assumed that this file is error free for STL file that we have taken. Once the file has been prepared, it is sent to the additive manufacturing system to begin printing. The labor cost calculation could be given by this. The cost of the labor, which is in rupees, is equal to O1, that is the operator cost rate. This is the operator rate. 1, as I mentioned, is for pre-processing. Operator cost rate, the cost rate would be obviously in rupees per hour, and T prep is the time for the preparation. So, this is time taken for the pre-processing. So, this again the cost will turn into rupees per hour into number of hours gives me the cost of the labor for the pre-processing. Next is the cost of the overhead for the pre-processing would be the overhead cost rate into the time for the pre-processing. So, this is the overhead cost rate. Cost rate, that is rupees per hour, right. Time is again the same time for pre-processing. So, based on how long pre-processing takes, overhead costs need to be assigned, because both the cost, the labor and the overhead are proportional to the time here. Pre-processing time should be proportionally assigned to everything that is referred to as an indirect cost, such as office supplies, lighting, rent, etc. So, for the single build, if an expert operator who is maybe getting a salary of rupees 1 lakh per month, if he spends 2 hours, or another operator who is getting salary maybe of 30,000 per month, if he is spending maybe 10 hours or 20 hours on that. So, the expert operator is doing much better, that means he is trying to contribute better, he is trying to compensate the salary the person is getting, and the time taken is lesser here. The overhead cost rate and the pre-processing time are used to calculate the overall cost. The calculation of this cost element is given by here. Cost of the overhead is equal to the overhead cost rate into the time for the pre-preparation. Next is the processing cost calculation 4, in which the second activity, that is processing cost, can start once all the preparation activities are finished. So, this cost of processing is equal to the cost of material plus cost of machine plus cost of the labor in processing, and CE plus CPC plus C overheads 2. Now, here 2 indicates the processing cost. So, this is material which is given here, this is machine, this is labor for the processing. CE is the cost of energy consumed. CPC is the cost of the processing control. COH is the overhead cost once again in the processing, COH2. Right, these all costs are in the rupees. The additive manufacturing system starts to build a part during this activity. The activity will cost money in terms of materials, equipment, labor, energy, process control and overhead. So, here majorly material cost, machine cost, labor cost, energy could also be seen there, overheads are again the small expenses. Processing control costs is the one that is critical to understand or critical to calculate for the processing itself. The processing control could be the digital format or digital system control, or maybe the parameter control. In the terms of the machines, it could be different for SLA, SLS in FDM in the terms of the machine control or the motion control in them. Then the control of the software systems and everything for the processing. So, this becomes the processing control cost. So, further if we try to see the elements of the costs here, the weight of the material used and its cost rate are multiplied to determine the material cost. So, weight of the material and cost. So, this is weight and this is the cost of the material. Weight of the material 1 into the cost of the material 1. So, this is the cost per kg, cost per kg, or I would say this is rupees per kg, the weight is in kg. Then similarly different kind of materials we have, weight for the support structure here. So, this is the weight for the build material, this is build and the other one is the support. In the support structure again we have weight and we have the cost, I would say per kg, or I would better say it cost rate in rupees per kg. So, this gives me the material cost. Next comes the material, when the system uses the same material for both the build and the support, the cost of the material is calculated as like this. In this instance, the material cost rate CM for building and supporting the structure is same. That is, the CM1 is same as CM2, which is CM1 only. So, that comes out and we get single material and the cost associated with them, right. If the material is same for the build and for the support, the processing cost calculation, when we try to say the material cost based upon the cost rate of the remaining material, cost remain of the virgin material, when rebuilding or reloading of the job has to be there, then these costs comes into the play. So, what happens is, so the value of recycled material is lower than the value of virgin material in general. So, the physical, chemical and mechanical properties of a material will change based on how often it has been used as well as how long it has been in contact with the power source. So, it depends upon the material which is in contact with the power source. Sometimes if you say the SLA printing, so in SLS printing there are different ways the laser comes. It could be only at the point where heating is required, it could be in the LCD form where the whole screen is trying to heat the material. So, it depends upon how the material is being heated and what part of the powder is unexposed to the laser. If it is completely unexposed, then the cost of the virgin material and cost of the recycled material sometimes remain same, but most of the times the cost of the recycled material is lesser than the cost of the virgin material, because it is given here the physical, chemical, mechanical properties of material will change and it is in the contact of the power source, more the time is with the contact of the power source, the larger is the time, the more will be the reduction in the cost or deterioration or depreciation in the cost of the recycled material. So therefore, the cost of the feedstock or tank material in these additive manufacturing systems should be re-evaluated after each use. In this case, sometimes the VAT or feedstock weight is decreased as well. So after the initial run by an amount equal to the component's weight, so that weight is compensated here. So since that tank or the feedstock storage system in this type of additive manufacturing process should be filled with the maximum capacity, that capacity is given by maximum capacity here, Vmax, and the virgin material capacity is X here. So they are added to refill the tank completely. So value of the recycled material is lower as it is mentioned. So what happens is we have a complete virgin material. Let me say it has two types of material, material A and material B I will put in between. Then we have the leftover material from A. This is, let me say, leftover material from A. I will put another shape. This material virgin is added to the leftover material. Then we get the leftover material and the virgin material added over it. So this is added here. This makes it something like this, right? So this is my V max. V max is the maximum fill capacity of my feedstock tank. Now X material is the virgin material, X amount of material is added here. This amount is X only from here, X. X is the virgin material or the fresh material that is added, right? So I'll put it here. This is virgin material, this is the leftover material, and we have refilled. But this is how it goes. Now this relation that is given here, this gives me the calculation of the cost of the material here as first is the cost of the leftover material, that is leftover, which is CMU here, plus the difference between the CM0 and CMU, that is the cost of the virgin material that is added minus the cost of the material which was left over. So this is CMO. So CMO minus CMU, this into the amount of material that is added, that is the X material. So this is cost rate of the virgin material. This is cost rate in rupees per kg. This is also rupees per kg. Now X by V, X and V are both weights of the built material that is added. Here I would say build material added in the kilograms. Then V max we have already mentioned. This is what is the maximum material capacity. In kg. Next is there are certain cases where virgin material cannot be added. The material cost rate can be discounted based upon its shelf life sometimes. So each material reaches its expiration date, it loses its properties. In some cases, to dispose the expired material, companies have to pay a disposal fee. So this fee is associated or calculated here in this equation. The equation gives below the account for material shelf life and disposal cost in calculating the material cost rate. So what does it tell? That the cost of the material is equal to the cost or rate of the virgin material added, that is given in the previous slide as well, plus T, that is the material disposal cost. This is material disposal cost. So this sum of the cost of the virgin material and the material disposal cost is divided by the shelf life. Shelf life would definitely come in the hours of the life into the time for which the build is made. This is the build time in hours. Now comes the cost of the machine. Cost of the machine includes the machine purchase value, then we have maintenance cost of the machine and the salvage cost of the machine, which is very general way of the calculation, divided by the total useful life of the machine. So here TBH is the time required to set up and build both. So setting and building, both the times are included here. The cost of the machine makes up the second component of the processing activity. This process includes the initial outlay, ongoing expenses and salvage. Additionally, the cost should be calculated taking into account both machine setup and actual build times. Both machine setup times and actual build times, both are taken into consideration. Here, this is the purchase value. Then we have the maintenance cost. Then we have the salvage value, which is subtracted from the sum of the machine cost, that is the initial investment cost, and the maintenance cost. This whole is divided by the total useful life of the machine. Of the machine, that is again in hours. These all are in rupees, rupees and rupees. This is also multiplied by time required to build the setup. This is setup and build time. This is also build time here. So next cost calculation is for the labor in the processing. That is again a direct calculation. The labor cost rate, the labor cost is equal to the operator rate, operator cost rate, that is rupees per hour into the processing time, that is in hours. So although most additive manufacturing systems fully automate the building process, sometimes operators are still needed to start the systems, add or remove the material, or monitor build progress. Based on the time spent performing these tasks and the labor cost rate, the labor cost in this situation can be determined here using this relation. Next comes the energy cost. It should be noted that this energy cost only applies to the additive manufacturing system, and the overhead costs apply to any additional energy used during the processing operations. So this is only the energy consumed in an additive manufacturing system, which means in the machine of additive manufacturing. Machines mean the whole, the set of the machines, if it is the sinter, washer, printer, everywhere where the energy is instituted or taken into account. Other than these, the energy for the building, for the lighting, for the computers, for other calculations, that is taken separate in the overhead cost. So the cost of energy CE is given as energy consumed in kilowatt hours. This is energy consumed in kilowatt hours into the time for which the build takes place. Build time in hours into the energy cost rate. So this is energy cost rate. So, this would be now rupees per kilowatt hour. So, in this case energy consumed would be then kilowatt only, not the kilowatt hour, right, because time is taken here, energy consumed in kilowatts, right, because the time is already consumed here, energy consumed into the time, then total energy cost rate in rupees per kilowatt hour. Similarly, we have the overhead costs for the processing. The cost of the overhead for the processing, the 2 indicates the processing, COH is the cost of the overheads or the overhead cost is equal to total overhead cost rate into the time for the build and the setup. This is already given in the previous slides. TBS is the time for the build and the setup. It is necessary to assign the overhead and the indirect cost in proportion to the setup and build times. Due to the fact that processing is frequently done on the shop floor, this overhead cost rate may be different from the rate charged during the pre-processing, because pre-processing only happens in the offices only where we have the computer setup only. The processing might take small tools, small other setups, and might be conducted here on the machine itself, the processing overheads. So, they may therefore have various rates, therefore, the overhead expense is determined as follows. Next comes is the cost of the post processing. The expenses related to this activity cover every item of equipment, labor, energy, overhead and post processing related materials and supplies. As a result, the following calculation is used to calculate the post processing cost, where the cost of the post processing is the material cost for the post processing. Here 3 indicates the post processing. This is the cost of the material for post processing. The machines used in post processing, it might be the heat treatment, it might be the vapor smoothing, it might be some other machines, painting, etc., that we are trying to use. Then the labor cost for the post processing, we have energy cost for the post processing, CT, here is the testing cost. Then the overheads for the post processing. In this case, the cost of the material for the post processing would be the weight of the material into the cost rate of the material for each of them. So, see summation 1 to n for Wi into Cmi, that the cost of the material, that the ith material, for example, if I am using 2 materials, it would be W1 into Cm1 plus W2 into Cm2 if I is 2 materials are used. If multiple materials are used, this will keep on adding till Wn into Cmn. It is important to consider the materials used for infiltration, plating, painting of parts. As a result, this cost component is stated here. The cost of the post processing of materials is the sum of the products of the weights of the material into the respective cost rate of that material. So, this is how we get the cost of the material in post processing. Similarly, multiple machines are used and we again get the cost of the machine for the post processing as the sum of the products of the machine cost utilization means for machine, that is again in this case for each machine. For example, if it is machine 2, the cost of the machine 2, that would be initial cost of the machine plus the maintenance of the machine minus the salvage divided by useful life for machine 2, right. For each machine it would be given in this way, and we have the time for which this machine is used. The expenses related to this activity cover every item of equipment, labor, energy, overhead and post processing related materials and supplies. So, as a result, the following calculation is used to calculate the post-processing cost for the machine. Now, different labor cost rates may need to be used depending upon the skill of the operator, and it must be there to complete each task. For the post-processing, the material, the painter who is doing it, the electroplating if it is happening, the vapor smoothing if it is happening, the machining if it is there, different kind of processes are there, the labor rate or the skill of the person doing this would be different. So that is how the cost of the post-processing varies here. So as a result, the labor expenses for post-processing is given as the summation of time required for the operator Q to complete the task multiplied by the operator Q cost rate. So this is time to complete the task into the operator cost rate, right. So this would be time taken would be hours, operator cost rate would be rupees per hour. For each operator, order time keeps on adding and we try to get the total cost of the labor. Similarly, the energy cost for the different machines is calculated here from 1 to y, summation of energy consumed by the machine, this is energy consumed by the machine into the time the machine is used, time of used into the energy cost rate. This energy is in kilowatts, time taken is in hour, but this is rupees per kilowatt hour. So it is important to consider the cost of the energy these machines use, the energy cost during post-processing operations. Taking into account the variety of machinery and equipment that might be used is expressed as this relation here. Next comes the testing cost. The average testing cost can be calculated as the following, and it is the price of testing for one unit A and acceptance probability is Q. So the cost of the testing would be Q into A into the sample size. Sometimes we do the sampling inspection or testing, sometimes we do the census inspection. Census means all the components, the capital N, all the components are taken into account. Then for the 100% inspection, this cost is there because the small n turns to the capital N only. So the inspection, the testing has been taken upon the n components here. So this components become 0. This makes only the component of the equation 1 and 2 into the calculation, where Q is the probability of acceptance, probability of acceptance, A is the cost of testing, and N is the sample size. Now capital N is the total number of pieces, total number of units which are built that we have seen there. The probability of non-conforming units is P, probability of non-conforming units. Then capital N is already there. Capital B, if repair is required, this is the cost to replace or repair a single, I would say replace or repair of a single unit. This is multiplied by the total number of units here. This is how the testing cost is also included. Now the overhead cost is directly the product of the overhead rate and time taken for the post processing. So overhead cost is the final post processing cost component. Again, because these processes can be completed in a separate facility or location, the overhead rate for post processing may vary from the rates charged during the pre processing. Therefore, it is possible to determine the overhead as this relation. So, to illustrate or to demonstrate the calculations further that we saw in the model, total cost model here. So, the models were developed, 8 components with the same weight, shape, size and geometry were examined. An additive manufacturing printer is used for it. As you watched in the previous lectures as well, the Imaginary Lab and MedTech Lab at IIT Kanpur were working together on a project. First, Imaginary Lab at IIT Kanpur provided the data required to calculate the cost of the pre-processing. So, that is facility 1. Then we have facility 2 here, where that is MedTech IIT Kanpur, which gave the data for the processing operation, and post processing was further taken. An overview of the data from these 2 businesses for each procedure is shown in tables 1, 2 and 3. But this is the table for the costs given for the pre-processing. We have the number of parts as 8, operator cost is ₹100 per hour. Some of the costs are just put to have the easy calculations as here. So, time required for preparing is 1 hour and overhead cost rate is ₹200 per hour. Similarly, we have the cost for the processing, where bill material weight is 1 kg. I have only put very simple values here, these are not the exact values, just to put the calculation or see how the calculations go. So, support material weight is 10% of the total build weight, the cost of the cost rate for virgin remaining added material is ₹100 per kg, the build weight is 1 kg, the maximum material feeder is 65 kg, machine purchase value is, I have only put 1 lakh, however the machine is more than 1 CR. The machine maintenance cost is ₹20,000, salvage is 0, because at the end we have considered it will not be sold or it would be just disposed of. So, useful life of the machine is 20 years. So, certain values are given here. Similarly, we have the cost for the post processing, in which various post processing operations that will be applied would be vertical saw for cutting, for honing, for manual deburring, for finishing, etc. Time for machining, for sawing, for hoeing, for deburring time. The operator's cost, the energy consumed in the machine 1, that is saw, then machine 2, that is honing. All these times are given, the energy cost rate. So, let us see how do we calculate. First is the cost of the labor for the pre-processing would be the operator cost rate, that is O1, into the time from the pre-processing. The operator cost rate here you can see in the table for pre-processing is 100. This is the operator cost rate, right, and the time for the preparation is 1. So, 100 into 1, this is equal to 100 into 1. We have the units for them as well, 100 rupees per hour into 1 hour is equal to ₹100. The overhead costs for the pre-processing is H1 into the time for the pre-processing, that is the overhead cost rate into the time for the pre-processing. So, the overhead cost rate here is 200 and the time is 1 hour. So, we have this is equal to 200 into 1, these units would be again similar, into, so this is equal to ₹200. So, the cost of the pre-processing would be 100 plus 200 is equal to ₹300. Next is the cost of the material for the first run. So, here we have cost of the material as the cost that as CMU plus the difference of CM0 and CMU, where this is the cost of the remaining material, this is the refilled virgin material minus the remaining material, then X is the build material weight and V max is the maximum capacity. Let us see these values here in the processing. So, we have V max capacity as 65 kg, we have CMU, CM1 here as 100 only, and we have the value of X, that is the refilled is 1 kg, because it is, I think it considered that the whole material is used here. So, here in this case this would be 100 plus 100 minus 100, that is the whole material is used here. There is no refill here. So, because this is filament process as well, though this kind of equation is not directly applicable, but for the calculation only I am showing it here, into 1 kg is filled and 65 kg is the capacity. So, this gives me the calculation as, so this, because this becomes 0 into 1 by 65, right, 100 plus 0 into 1 by 65, this terms as rupees 100 per kg. This is the cost rate. So, the cost of the material would be the weight of the material for the support and for the build. This is build material, this is support material. In both the cases, the material is same in FTM process. So, the cost rate here is rupees 100 per kg, which has come from here. So, weight of the material, that is the build material weight is given here, and support material weight is 10% of that. So, this gives me 1 plus 0.1 into this. This becomes 1.1 into 100 is equal to 110 rupees. Next comes the cost of the machine. This is equal to the initial value of the machine, that is given as 1 lakh there, plus maintenance cost, which is given as 20,000, minus salvage value, which is given as 0, divided by the life. The life of the machine is 20 years, right. So, this multiplied by the total build and the setup time. So, build and the setup time here is 2. This is the build and the setup time. Here this is given 2 into 2. This give me this value as 12000, 12,000, right, for this build. Again we have the labor, operator, the rate into the time for the processing. The operator rate is 100 and the time for the processing that is given is 5 hours. Here the time required for processing is 5 hours, operator cost rate is 100. So, from here this gives me this value as 500 rupees 500. Now, the cost of the energy would be the energy into the build time into the energy cost rate. So, energy consumed, that is given here 5 kilowatts, right. Build time is 70 hours and energy cost rate is rupees 11 per kilowatt hour. It is 5 into 70 into 11 is equal to 3850. Overhead cost, here it is the value of H2 is 6 and for TBS is 2. This give me rupees 12 only. The processing cost for the material, that is 110, for the machine that is 12,000, plus labor cost that is 500, plus cost of energy that is 3850, plus CPC that is not yet calculated, COH2, COH2 is the overheads for the processing, that is 12. So, C for the process control, that is the in situ control or the running machine control, that is given here rupees 408 plus 408. This gives me the cost of the processing as 16880. Similarly, let us see the values for the post processing machines. So, there are 3 machines for the post processing. So, manual deburring, it is the time, the value is 0 here only. So, let us put these 3 machines value here. So, it is sum of the machine rate, that is 15 by 60, because the time is given in hours, I am converting it to minutes, into 1 plus 15 by 60 into 10. This is the times taken from here, 1, 10, 15 is the value rupees per hour, 15 is the for vertical, and 15 is the value rupees per hour for honing, right, plus 0 per hour for the manual, plus 0 by 60 into 1. This give me rupees 2.75. Labor cost is also given. Here the value of x is equal to 1 because only one operator is there, single operator, right. So, for the single operator the cost is given as 8 is the time into the rate for this is 400. So, this give me rupees 3200. The cost of energy for the 3 machines is the energy rate for the 3 machines. Here is the energy cost rate for the post processing, rupees 11 per kilowatt hour. Time taken by machine is 8 hours and energy cost rate is 11 hours. So, these times are put there, 2 into 8 into 11 for machine 1 plus 2 into 8 into 11 for the second machine. This give me this value as rupees 352. So, next comes the cost of the testing. The testing cost, because it is 100% inspection here, only 8 pieces are there and all of them are inspected. So, it becomes A into N, that is the cost of testing 1 unit into the number of units, plus probability of the cost of probability of the non-conforming units into the number of units, and the replacement cost. So, probability is very less here. So, it is given 4% probability, right, number of units are 8 and the cost of the repair of the unit is rupees 200 per unit. So, these are some costs which are put here. So, then A into N would turn up as 2 into 8 plus probability which is given as 4%, that is 0.04 into 8 into the cost of replacement, that is 200. So, this give me this value as 16 plus 64 is equal to rupees 80. Then the overhead cost is H3 into time for the post processing. So, where the overhead rate is rupees 15 per hour into 2 hours is equal to 30. The cost of the post processing total would be material cost plus machine cost plus the labor cost plus energy cost plus the testing cost, which is 80, plus the overhead cost, which is 30. This is equal to rupees 4554.75. Now, the total cost would be 1 by n, that is 1 by 8 into the cost of the pre-processing, that is rupees 300, plus the cost of the processing, that is rupees 16,880, plus the cost of the post processing, that is rupees 4,555 I will put for the ease of calculations. So, this is 1 by 8 of the value 21735 is equal to rupees 2716. So, some values are assumed, some values are just put, some value might not be exact relevant because sometimes the repair cost is quite heavy. So, here you can see the preparation cost is too low, the major cost is cost of processing only, the post processing cost is this heavy. So, these are only some values are taken from the laboratory, some values are just assumed to have the easy calculations. So, this is one of the demonstration or one of the calculations that we can do using the total cost model. So, metal additive manufacturing cost forecasting in euros per centimeter as given by the source project managers. They say from 2013 to 2018 there has been 49% of the reduction of the cost in the direct and the indirect cost combined. So, from the 27% the cost, majorly indirect costs are reduced, the direct costs are though going higher. In this case you can see 41% in 2018 is the direct cost, in 2030 it was only 27%, but from 3.1 to 1.6 then to 1.1. The total cost is further expected to reduce by 32% in the coming years. This was a study given in the year 2015. Now, the way the technology is being improved, the costs are expected to fall. Now, this completes the lecture series on the costing in metal additive manufacturing. So, in this case, certain points to ponder is the cost comparison valid for various technologies? So, can we compare the SLS, SLA, the direct laser sintering, fuse deposition modeling and various processes? So, if we try to do, what kind of the costing method would you use? Would you use this total cost method, activity based method? Which method would you use, and is it really comparable? How does waste identification help in cost reduction? Because there is the cost of the waste, there is the salvage value, there is the waste material or recyclable material is also there. How do we identify that? Please try to look that once again. What are or could be a new age cost categories? Which category, which model would you like to choose to be applied on the system that you are trying to design? Can new cost models be suggested? Yes, there are multiple cost models which are coming. So, can you please suggest a simple cost model depending upon the level or the activity, or depending upon the setup that we have, direct or indirect, or we try to say pre-processing, processing and post-processing? How is additive manufacturing giving cost advantage based upon or in comparison to the subtractive manufacturing or the CNC manufacturing systems? So, what are the firm capabilities of additive manufacturing? These firm capabilities we will also further discuss when we will try to see the industry 4.0, that is the fourth industrial revolution, in which digitization or digitalization of the systems is majorly taken upon, and additive manufacturing plays a vital role in it. This will be discussed in the last and the next lecture of this course, metal additive manufacturing. Thank you.